This is AS Pure Maths. We are looking at our notes here. We're in Unit 3 and we're solving quadratic equations by completing the square. Some of you may be familiar with this from GCSE Further Maths, but just to kind of a wee bit of a reminder then about what we do. So let's take a wee look at our example 1. You can take a wee read through those notes there and it's following the same format. So it depends what we do. So our first one here is x squared plus 10x plus 6 equals 0. And what I ask pupils to do is to half the 10 to get 5, and then you consider x plus 5 all squared. So if we have x plus 5 all squared, what does that give us? X plus 5 upon x plus 5, and that gives me x squared outer and inner plus 10x plus 25. So we use this piece of information to complete the square here. So we have x squared plus 10x plus 6 equals 0, and we want to rewrite this in a different format. So I'm going to write then x plus 5 all squared. Now we know what x plus 5 all squared gives. It gives us this here. So this gives us an extra 25 that we don't want. So we want to remove that 25 plus 6 equals 0. And I want you to try and content yourself that what this is exactly the same as this. That's the important bit there. If I was to multiply this out, I get this. I take away the 25 from this and I just get my x squared plus 10x. So it's important that this and this equate to the same thing. Then we would have x plus 5 all squared. I hope you're okay with this move. I'm going to take this over the other side and that's going to be 19. I take the square root of both sides. X plus 5 equals a positive or negative square root of 19, and then I take 5 from both sides, so that would be then minus 5 plus or minus the square root of 19. Again, if you were asked for this to 3 significant figures, you would put those values into your calculator, but here this is a much more eloquent answer and a nicer answer because we have the exact answer right here. On to example 2, solved by completing the square. Our method for completing the square is this only works if it's a 1x squared. So our first move is going to divide through by 5. Dividing everything by 5 here gives me x squared plus 3x plus a fifth equals 0. So what did I do in the previous example? I halved this number here. So I want to consider then x plus 1.5. I'm going to write that then as 3 over 2 all squared. That's the same as x plus 3 over 2. X plus 3 over 2. If I multiply that out, I get x squared plus 3 over 2x plus 3 over 2x, which of course gives me my plus 3x. And then if I square that, top times top, bottom times bottom, it gives me then a 9 over 4. So keeping that in mind, let's look at this. So if I complete the square here, I'm going to go over x plus 3 over 2 all squared. That generates a 9 over 4 that I don't want, so I need to take away my 9 over 4 plus a fifth equals 0. We now have a wee bit of year 8 fractions to do, so we want to find a common denominator here. X plus 3 over 2 all squared minus, so you're going to times top and bottom that by 5, so minus 45 over 20 plus 4 over 20 equals 0. X plus 3 over 2 all squared minus 45 plus 4 is minus 41 then, and taking it over the other side gives me 41 over 20. I hope we're okay with that move. Taking the square root then of both sides, I'm going to have x plus 3 over 2 equals the positive or negative square root of 41 over 20, and then I have x equals minus 3 over 2 plus or minus the square root of 41 over 20.